In miscellaneous exercise 7 of integration, question number 18. Actually, 18th question is a bit difficult question. If you don't remember, it will be difficult to deal with it. You may end up with no answer. So you need to carefully attend that. Some people will say, don't say it is difficult, that it is negativity. Not like that. You have to give special attention. Keep remembering about that method. Then maybe this question of something of this kind you will be able to deal. See, naturally I will write this like this. 1 by square root of sine cube x. This I can write as sine a plus b, sine x cos alpha plus cos x sine alpha. What is this? Sine a plus b, sine a cos b plus cos a sine b. This is what this is for. I am not putting integral sign. I'll see when I want to put it, that time I'll put. Now peacefully let me write this. Now what I should understand is cos alpha is a constant, or whatever alpha function is a constant, x is a variable. That you shouldn't forget. That way only you should treat it. Okay, now what I do is, I will take a sin x common factor. If you ask me, how do I remember means, only when you take a sin x outside, you don't have a sin x, but I'll tell you how to take by dividing. So sin x when you take, it will become sin power 4. Sin power 4, you can take it outside square root as sin square, and then ultimately it will become cos square in the numerator. So there is a benefit in that. That benefit I'll tell you. What I'll write is 1 by root of, when you take a sin x, you need to divide a sin here. Only then it will become cot x. That you shouldn't forget. When you take a sin x, it will become sin power 4x into this will become cos alpha plus this will become cot x and sin alpha. See, this step you should remember. Now sin power 4 will go to numerator as sin square. Sorry, cosec square. Sin square when it comes out, and cosec square. What is cosec square is derivative of cos x. See the beauty of it, the cot x derivative. These two things will be constant, so you need not worry. This will become in derivative form, and this will become 0. That is what you should understand. If you remember that, then the work will be easy. Okay, so let us try like this. This I will take it up, then it will become sin square outside. When it comes up, it will become cosec square x by square root of, now only this, cos alpha plus cot x sin alpha. So if I want, I can write the question once again. Integral question is equal to integral this dx, because the question I converted into this. Now I will do this beautiful substitution. You see, I will write cos alpha plus cot x sin alpha equal to t. If you differentiate, this will become 0, constant. Cot x, this will become, sin alpha is a constant, you will keep it as it is. Cot x derivative is minus cosec square x equal to dt by dx. So I want cosec square dx only. So I'll keep cosec square x dx is equal to minus dt by sin alpha. See, this sin alpha I divide and dx, this managing like this. Now I can change the question like this. Integral, instead of cosec square x dx, I can write minus dt by sin alpha. Don't worry about the sin alpha, that you can keep out of integral, then out of trouble. That is a constant. Divided by root of, see how beautifully this has changed, it became t. So small it became. See, minus 1 by sin alpha, you don't worry. Now you should remember 1 by root t integration is 2 root t. So this is 2 root t. Over, our work is over. So this will become minus 2 by sin alpha. Now just replace t. What is t? T is this one. So cos alpha plus cot x sin alpha plus c. So that's the work. So the only thing that we shouldn't forget is after you expand you should take sine outside, so it will become sine power 4, sine power 4 outside of square root it will become sine square, and sine square numerator it will become cosec square. Cosec square is the, when you take a sine, we don't have a sine here, but therefore you have to divide a sine, so you will be getting a cot x. This is cos became cot, and that cot derivative is cosec square, that is what you have in the numerator. So then this question will become simple. So remember these steps, work out one time, again keep remembering, see that work again. You need not work out every now and then. Once you do it properly, then come back and see. Okay, good.